All right, we've started recording. So to be aware, this meeting is recorded and will be published on the internet. So everything that you say may stay on public internet forever. With that, let's start our today's meeting. I don't have a whole lot to talk about today. So today we may actually go into a little bit more details about a couple of features that we're working on, if that's okay with you folks. I was expecting Aish actually to join and give us some updates from the about the release process, I believe.
I'm here to fill in for Aish.
Oh, okay. So go ahead then.
Yeah, not a problem. So I'm Kendrick. I am running enhancements lead for 113. So I'm just taking care of Aisha's role today. So if anybody's unfamiliar, Aish is running the release for 113. But the goal is that we're just trying to get around to all of the SIGs, just to introduce ourselves, B, to also just kind of give an update on 113, sort of what the timeline is. As most of you are probably well aware, this is going to be more of an aggressive schedule that's going on with this one, because it's, I believe, 2 or 3 weeks shorter. It's only 10 weeks long for this particular release, because we've got 2 KubeCons plus the holidays that are approaching. So one of the things that are going into it, and really the theme that she's really trying to drive, is stability with this. So really there's a request to say, let's not try to take any massive alpha features and try to get them and drive them into 113, because there's probably not going to be enough time. I believe Code Slush begins early November, and Code Freeze is, I think, like November 11th or November 15th. So it's really not too far away if you start thinking about what's going into it. So the goal is to start thinking of what features were actually deferred for 112, and you could potentially get those into 113. These could be things for that just didn't make it because of docs or anything like that. Looking at the K features repo right now, there's 14 open issues. There's, I think, 5 or 6 of them, or maybe 4 or 5 of them, that are tagged with milestone 112. I'll probably start bugging people early next week to figure out if these are actually going to graduate to 113. If not, I'll probably remove them from the milestone anyway. Things that are on 113, we'll probably just give a comment to just figure out what is your level of confidence that you could actually make it to Code Slush / Code Freeze time, given the time constraint that is there. So that's really the major theme that she wanted me to relay to everybody here. The other thing that she also wanted me to talk about was that there were some daemon set failures that were happening in the upgrade dashboard, and she wanted to know if there's any pending PRs that will fix this. I guess I should, before I get to there, if there's any questions about the 113 process or release cycle, feel free to ask.
Sure. So actually I'm less worried about alpha features, because generally alpha features are behind feature gates, and the expectation is that the logic for those alpha features will not be executed. I am more concerned about actually the features that we're moving to beta, because these are the features that become enabled in this release, basically. And those are potentially could be more problematic than others. Particularly, we're targeting taint-based eviction, which is one of the features that allows nodes to be evicted if there are issues, for example, with nodes, or if we're draining those for upgrading, etc., to move to beta. And I am a little bit more concerned about that feature, because potentially it could cause outages in clusters and issues of that sort. So now that you mentioned that, I wonder if we should actually target this for basically target moving this feature to beta for 113, or maybe we should postpone it to 114. So let's see. Ravi and Wei, you guys are both here. First of all, what do you guys think? I don't know if you have enough familiarity with or you know the level of our confidence about this feature. If we hear from you guys, then we can decide better. Do you guys know?
So I know the status, meaning what is remaining in the what is remaining to complete the feature to move to beta. but I do not have much familiarity with the code base when it comes to the node controller. So we can try doing one thing. We will try to complete the feature earlier, like 2 weeks. Say if it's like 10 weeks, we'll try to complete it before 8 weeks and use the 2 weeks to test if it's failing, especially during the upgrade test, if they're failing. And if we think that it's difficult at that point of time, we'll postpone to the next release is what I think.
To me.
Because,
what do you think, Kendrick, about this? So basically, instead of just our usual code freeze, which is, I believe, in mid-November, we can basically finish this 2 weeks before the code freeze, so that we will give it a little bit longer soak time. And hopefully our upgrade tests and other tests will run for this feature for a longer period of time after the feature is enabled by default. And if we see that there are issues, we can hold it back for the next release.
Absolutely. I think that sounds like a good plan. I was actually just pulling it up. It looks like this is a one that's been sitting around for a while if it's issue number 166. So it seems like it's something that you all have been pretty heavily working on for quite some time. So yeah, I don't see a problem if you can wrap something up relatively quickly, see if we can get it in. If if not, then pull it out if things just aren't passing through the dashboard.
Sure. Yeah. Then Ray and Ravi, I think you guys can arrange with one another, and probably we should start working on this almost right away because we are basically almost 3 or 4 weeks away from our deadline for this feature. So we should basically get it done pretty quickly. And then we can decide about it. Other features, I am much less worried. We have a couple other features, like, for example, moving one of our priority functions to beta, which is not very critical. I'm not very worried about that. But this particular one is a little bit more of an issue. Other features that we are working on are not going to, I'm not very much concerned about them. Some of them are just finishing the designs and stuff like that. So thank you very much for giving us the heads up. And you wanted to actually talk about one issue that apparently is failing.
Yeah, I will put it in the chat, the link that she had sent me.
Sure.
She's gonna be more familiar, and you guys may be more familiar with this one than I am. But she said the main thing to ask is about daemon set failures in the upgrade dashboard. She wanted to know if there's any pending PRs that are going to fix this. She said the tests themselves are held by SIG apps. She said, but Claus was working on upgrade fixes in 1.12 heavily.
So should not.
I remember correctly, I think this is related to the pod spec unschedulable field. So Claus has proposed a fix some time ago. After that, I did not follow up.
Yeah, but I actually don't know if these are scheduling related. I haven't looked at a test. Of course, I'm just looking at the titles of these tests. One says that should not update pod when spec was updated, and an updated strategy on delete. So I feel like these are daemon set controller related. These are not about scheduling of these daemon set pods. But we can certainly look more closely at these tests. My gut feeling from just reading the title is that these are probably related to daemon set controller, and these fall into the category of SIG app responsibilities, basically.
Yeah, I think last release we have started scheduling daemon set pods by default scheduler. We have promoted that feature to beta, and some of them could be related to that is what I think. But I have to look into them in more detail.
Yeah, these feel to me like more of a life cycle events of daemon sets as opposed to scheduling them. So if that's the case, then it's daemon set controller. But anyway, we're gonna take a look at this anyhow, and we're gonna update the bug. Well, actually, this is not a bug. Actually, I don't think there is any issue filed for it. Or do you know, Kendrick, if there is any issue filed for this?
That I do not think there is at this point. So I couldn't give you a better answer.
Okay, sure. We can take a look. I will take a look after the meeting to see if these are related to the SIG scheduling, and if so, I will I will file a bug or an issue.
Sounds good.
Thank
if you have any other questions that you need to know about the release, my name's Kendrick Coleman, KA-Cole2 with inside of Slack, as well as GitHub, so feel free to ping me on anything you need.
Okay, thank you so much.
You got it.
All right, let's go back to our other items that we wanted to speak about. So, open up this document. All right, I actually, let me give you an update about equivalence cache. So Harry has written a document about how to change equivalence cache. And I've actually linked a document to our meeting notes. Okay, and feel free to take a look at the document, and if you have any question, comments, you can leave them there. I feel like we need to if we go that path, basically, we need to make major changes to various structures, like data structures of the scheduler. And for that reason, I've asked Harry to prototype this new design, which is basically avoiding, if you guys remember from our previous discussions, the new design is based on trying to avoid scheduling pods which are unschedulable and have the same spec. So if you have, for example, 1,000 pods which have the same spec, and we find with the first one unschedulable, there is no reason to check the other 999 pods because all other ones with the similar spec are going to be unschedulable as long as the state of the cluster is not changed. So that's the idea of this new design of the equivalence cache. That might require some changes to the scheduling queue. So we are hoping that we can prototype this without making those changes to the scheduling queue, and hopefully we will get good results. And if the results are good, then we can go ahead and make more fundamental changes to those structures. That's one update. I also would like to thank our contributors. Thank you so much, folks who have contributed to the issues that Jonathan filed for refactoring parts of the scheduler. Some of those PRs are already merged or almost ready to be merged. I really appreciate your efforts. And the last one, which is actually I would like to talk about with Wei, and this is going to be a little bit more detailed discussions about like details of technical details of this feature, is that we were working on interpod affinity and supporting multiple pods matching. This turned out to be a little bit hard, given that we would like to support a single pod pod affinity towards itself. And what I mean by that is that when a pod can have affinity to self, and no other pod in the cluster has that affinity, we should mark that pod as schedulable. The reason for this is that when you're scheduling let's say a replica set or any other collection whose pods have affinity to one another, none of them will schedule if we don't support this. The first one basically needs to be scheduled so that other ones that have affinity to that one can be scheduled as well. So if we cannot schedule the first one, then none of them will get scheduled. So affinity to self is actually there to support this particular use case. And our scheduler has been supporting this for a long time now. And it's actually a valuable feature. Sometimes you want to schedule all the replicas of a replica set in a single zone, for example. You should be able to do that. With supporting matching multi-pods against affinity, we ran into an issue that figuring out whether there is any pod in the cluster, in the whole cluster, that matches all the affinity terms of an incoming pod is hard. Because now that we support multiple pod matching, each one of the pods in the cluster may satisfy some terms of the affinity, not all of them. and finding out whether there is enough pods in the cluster that together match all of the affinity terms is almost impossible during the metadata checks. We need to look at each node of the cluster and check the labels of that node to be able to perform this check. And what this means is that we cannot know the answer to this question that is there any pod or a group of pods in the cluster that match the affinity rules of an incoming pod. Needs us to wait for the actual predicate to run, and only after that we can answer this question. So this is actually a problem. We cannot actually do it during metadata, and at the time that we are running the predicate, we should already have the answer to this question. Otherwise, we will not be able to support affinity to self.
Yeah. So
Jay and I have been working on this for a while. We don't have a great answer at the moment, I believe. And I read your answer on the PR, and I feel it won't actually work. The last.
Sorry, which do you mean? You mean the last one I said with some additional channel or condition? Yes. Yeah, that may or may not work.
So I think it won't work. The reason is that okay, let me read it again so that I can explain better. So you've mentioned that right now it's a rough idea, pass a shared channel or condition into pod affinity checker. Yeah, so you've mentioned that we can create this channel so that each node in the cluster can basically, when we are checking each node in the cluster, we can say whether that node whether there is any pod in the cluster that matches affinity or not, right?
Yeah, actually it's not per pod, it's just for the node, right?
Well, you should check if any of the nodes on that pod, if any or a group of pods on that node match. Well, actually not.
No, it's not. It's actually checking whether the incoming pod
right
node satisfies or not.
Yes, that is true. One issue is that at the time we are checking this predicate, the nodes are already filtered.
Yes.
So we are not checking all the nodes in the cluster. We are checking a much smaller group of nodes.
Yes. Okay. So, is that is that desired behavior, do you think?
That's the desired behavior. The reason that we decided to go with this is that we would like the nodes to be shrunk during the process of running predicates. This gives us better performance, obviously, right? So instead of checking all the predicates for nodes that have already failed some other earlier predicates, we just focus on the nodes that have passed previous predicates, right?
Yeah.
So the issue now is that when we check these nodes, at the time we are checking affinity, the nodes are already filtered.
Yes.
So there could be some pods in the cluster that match affinity, but they are not checked because some of those nodes are filtered out. For example, those nodes don't have enough memory for the incoming pod. So those nodes are filtered out. And by the time that we reach to this affinity predicate, we already ignored it.
So that means you still want to global result to see whether the pod affinity matches on node or not, right?
Yeah. So yeah, exactly. So when we were not doing multiple pod matching affinity, we were making sure that a single pod would satisfy all the affinity terms, right? So that was very easy to basically at the metadata check, we could easily say if there is any matching pod or not, right?
Yeah.
Now that we have multiple matching, we cannot do that.
I got it. The before behavior is also to check whether globally, right?
Yes.
Okay, we should keep the behavior. So
Yeah.
Then we can do the interval predicate on demand. We should either run it in advance as a global action, but if we do that, the cost will be pretty expensive. I think it's kind of interview question that you need analysis, the time, space, complexity. So I don't have a good way to reduce the time complexity. Right?
Yeah, I was exactly. So when I filed this issue to support multiple pod matching, I of course wasn't aware of this issue. And after we worked together on this PR, and thank you for your efforts on this PR. After that, we realized that it's a little bit more complex than we initially thought, right? So if we want to support multiple pod matching, then it could impact the scheduler's performance greatly, actually, because we need to initially basically we need to run the predicate early on when all the nodes are in the cluster, or in our pool basically, and haven't filled any of the nodes isn't filtered out. We need to check it at that point, and then maybe run the predicate again and say, oh, there is no pod that is matching. So now that we have self FNATV.
By going back to my first solution, so do you think it's acceptable? Because I can introduce a kind of topology tree or something so that we can get from the node label to get the node names in O1 time. So
I actually don't know your solution, but if you think it doesn't take you a whole lot of time to implement it, I will be happy to take a look. Actually,
sure, I can continue this path. I'm kind of halfway.
Okay. Okay, sure, yeah. If you're almost there, then let's do that.
Then based on our discussion, the solution 2 doesn't make sense because it's using filtered nodes. Yes. Okay, I will continue with solution 1 if it doesn't take me too much time. I think 1 or 2 days should be fine.
Sounds great. And I would like to emphasize again towards the end of our meeting today that taint-based eviction is of high priority for us, to you and both you and Ravi actually. That's a high priority for us. Please focus most of your attention on that feature at the moment, because we want to get that out of the door as soon as possible so that we can get it soaked for a longer period of time before we get to the code freeze.
Yes.
Yeah. All right. Thanks so much, and sorry for too much of single way monologue from me.
That's fine. We actually have a couple of questions. Probably I'll put them on Slack or some other place to you and Wei. So I think whatever I understood from Wei's implementation, whatever he wanted to do, now whatever I understood is he wants to have kind of a tree which has like the labels as the roots, and with individual nodes or pods as
to be specific, label should be label plus label value, because it's a topology pair. We can make it a structure like topology pair, or we can use some separator to make it a string. And that is the key. And the value should be all node names.
Right.
Yeah.
Right. I think this is what Tim was proposing like some time ago. Tim Sinclair was proposing some time ago for pod pod anti-affinity, if I remember correctly. But I'm curious about the implementation, like how you want to do it.
So basically, I can propose this structure. So basically, like I mentioned, is the key is a topology pair and the value is a node names. So it should be added to the scheduler cache. And once node is added, updated, deleted, it should be updated. So that by passing this cache to our predicate, should be metadata, predicate metadata, so that by a single incoming pod, by checking its pod affinity, by each one, I can know which pod affinity has which node names matched, right? In O1 time.
Okay.
then I can kind of intersect all the node names and get a final answer, which node should be a fit.
Okay.
Yeah.
Intersecting could be actually a little time consuming if you think about it, and in larger clusters, and especially if you have many nodes
Yeah.
pods or matching affinity.
Yeah. So suppose we have n nodes in matching one affinity term, then the total time complexity would be, let me check. Yeah. Because you can do the intersection half and half, so that is log length of the affinity terms and multiply the length of node names in each match, right?
Yeah, exactly. Yeah. So my point is that if that the number of nodes actually
yes,
is large, then that could actually become very
messy. Yes. We cannot simply just put a count there, right? We should specifically know which node matches this.
Yeah,
this is right. Yeah. But anyway, I don't think, our API has been always vague about whether we support multiple pods matching affinity. And in our previous implementation, we decided to not match multiple pods. And it's fine if this is going to be very time consuming and causes performance degradation. It's fine to just keep supporting what we have been supporting so far. And we haven't seen actually a lot of demand or requests from our users asking for this feature to be matched against multiple pods. So maybe we should not put a whole lot of efforts on it at the moment. But if you know a great solution, of course I will support having it.
Yeah.
And by the way, even if we decided to not go with your PR, I think it's still valuable to add some of the tests that you have added in this PR to the affinity. Maybe the tests need to be slightly modified, but it'll be useful.
Yeah.
All right.
Yeah, of course, we need benchmark the final PR if we got a solution.
Yeah.
Thanks a lot, Bobby and Wei. I have one more question to Bobby. I'm sorry, I'm taking much of your time, but so you have asked a question on the PR for promotion of resource limits thing. So as of now, the problem, at least in OpenShift online clusters that we host, is unless the feature is beta, we will not allow it to be used by customers. So we do not have a real usage cluster, but our QE team has tested it. So that's the update I have. I'm not sure if that's good enough to promote it. Yeah,
I mean, sometimes what I do is that for example, on GC, I bring up, GKE has, like OpenShift has its own release processes, and certain features are not enabled, and even if you want to enable it, you don't have access to the master nodes. Well, we do, but that's not just GKE. If we want to really try Kubernetes, like open source Kubernetes, we bring up a cluster of our own on GC, or other cloud providers can do the same thing. So I don't know if you have access to such environments so that you can bring up real open source Kubernetes on a more raw environment and test it. It will be great if we can actually test it before we promote it and move it to beta. But given that we are currently early in the cycle, and if you think that your QA team has done enough, we can actually promote it and let this be merged so that our tests and everything run for a longer period of time for this feature.
Yeah, so one thing is we do not have enough E2Es, and this feature, this priority function is not enabled by default, meaning it's unless the feature gates are specifically applied, this feature won't be in effect.
True. At the same time, this feature actually is going to, as soon as it gets enabled, it will be used in many tests, right? Because it's one of these priority functions which are going to be enabled by default, and it's not like an obscured feature. It's just limits. So it's going to be exercised for pretty much all the pods that have some limits in their pod spec, which is a pretty common thing to have. So I'm hoping that if we enable it early, we can get some mileage out of this feature by the time that we get to the code freeze.
Sure, but we just have like a couple of unit tests that are actually testing this feature. I'm not sure if this will have like a big impact on the rest of the test, but I'll try to add a E2E as part of this.
So one thing that I would check is that you can check to make sure that there are some E2Es. Yeah, well, if you just check that there are enough, there are E2Es that have like limits on pods, it means that this feature is going to get exercised. But it'll be also great if you add specific tests for this feature, so that some nodes are preferred over the others in this particular priority.
Yeah, we just have a unit test, but we don't have a E2E. I'll try to add a E2E as part of the PR.
Okay, sounds good.
Yeah, thank you.
Thank you. Okay. I know we are already over time, but if any other people here have any questions or comments, please go ahead. Okay. Looks like there's no question or comments. So thank you very much, guys, for attending. I'll see you folks next week. Bye for now.
Thank you. Bye.